Good morning. Today we're going to talk about solving inequalities and using addition and subtraction. We have a nice set of notes that are just basically fill in the blanks, so we're going to read through it, we're going to do some practice problems, and we are going to begin from there. So I'm going to come over here to 122 of my interactive notebook. Let's blow this bad boy up. And so to solve and graph an inequality, you're going to use the inverse operation. We have heard that before. We have heard inverse operations when we're solving equations, right? Well, guess what? It's the same exact process. Even though we have an inequality symbol, we're going to get that variable isolated on one side of the inequality. I like to use the left. We're going to get that variable isolated by using the inverse operation. So remember what the inverse operation is. Do you guys remember that? What is the inverse operation of multiplication? Class. Division. What's the inverse operation of addition? Subtraction. It's the opposite operation, right? Inverse, it means opposite. So you're going to use inverse operation to isolate the variable. So what I want you guys to do is I want you to box inverse operation. I want you to box isolate the variable. And just as you would to solve an equation. And remember, when we do this, we always have to balance our equation. Whatever you do on the right, you've got to do on the left. The inverse operation of addition is subtraction. The inverse operation of subtraction is addition. When graphing an inequality where the number is a solution, use a closed circle. When graphing an inequality where the number is not a solution, use an open circle. We'll show what that means in a minute. The addition property of inequality, this is a big one to write down. The addition property of inequality states that when you add the same number to each side of an equality, the inequality remains true. So as long as you balance it and you do the same thing on the right and the left, you still keep that inequality in the same direction, it still stays true. The subtraction property of inequality states that when you subtract the same number to each side of an inequality, the inequality stays true. So if you're adding or subtracting and you do the same to both sides, it will stay true. You don't have to change the inequality sign. So to check the inequality solution, choose any number that is shaded in. So when we drew on the number line yesterday and we showed that it could be any number within that range on the number line, any of those numbers you can take from that number line and you can plug it into the inequality to see if it could be true for the variable, and that's how you check your work. Then you're going to evaluate the inequality with that number to make sure that the inequality is true. Solve and graph the inequality. Don't forget to check your work. So check to make sure it's true. Okay, so here we have an example inequality. Oh, and I wasn't even showing you guys. There you go. Sorry about that. So you'll notice that there is an example inequality. We have g plus 2 is less than 5. So something that I add to 2 is going to be less than 5. So the first thing we need to do is we need to get that variable isolated. So we're going to do the inverse operation. Well, what operation are we doing to g right now, class? We're adding. So what's the inverse operation of adding 2? Yes, Riley.
Subtracting.
Subtracting, and we're adding 2, so we're going to subtract what?
2.
2. Good. So I would do g plus 2 minus 2 is greater or is less than. Now remember, you have to balance our inequality. So whatever we do on one side of the inequality, we're going to do it to the other side of the inequality, and it has to be the same. So on this side, we subtracted 2. So class, what do we do on this side?
Subtract 2.
Subtract 2. Okay. This plus 2 and the minus 2 cross out, so we're left with just the variable by himself, all isolated and happy. And now, what is 5 minus 2, class?
3.
3. So g, the variable g, is going to be less than 3. So remember, when we have a closed dot, that means that the number is included. It's like a greater than or equal to, or less than or equal to. It's an open dot if the number is not included, like less than or greater than. So in this case, do we have an open or closed dot? Class. Open, right? Because it is not. It doesn't have the equal to. So we're going to go to 3 and we're going to make an open dot. Now, are we going less than or greater than? Less than, right? So is less than going to take us to the left or to the right? To the left, right? And I like to see how my little arrow is pointing to the left? That's where my line's going to go. So it's going to go this way. So now, any number after 3, this way on the number line, could be plugged in to see if it's true. So who wants to choose a number for me to check? Nicole?
-4.
-4. Let's do -4. Okay, so we're going to plug in. For G plus 2 is less than 5, we're going to put in for G, -4 plus 2 is less than 5. So remember, when we're adding negatives, it's really like subtracting. So, and then we just choose the whether it's positive or negative, depending on which one has the greater absolute value. So, -4, if we were to have 2 coming from 4, we would get 2, right? And -4 has a greater absolute value, so it would be -2. Is -2 less than 5? Class? Yeah. So is it true?
Yep.
Yes. So we are going to put a little check mark because it checks out and it is correct. So now we're going to go over to page 121, and we've got a couple more. I'm going to do one more with you, and then I'm going to have you guys do the rest on your own. Okay? So up here at number 1, solve and graph the inequality x minus 1 is less than or equal to 3. So the first thing we have to do is what? Raise your hand if you can tell me. Nicole?
Since it's subtracting, then you would have to make it adding.
Yes, because we're subtracting 1, we're going to add 1 because that's the inverse operation. So x minus 1 plus 1. Now, can somebody tell me what I have to do now? Anybody in the group? Raise your hand and tell me. What do we do next? Christopher? Do the same to the other side of the inequality. So we added 1, we're going to add 1 to the other side. So now we're going to evaluate. -1 plus 1 is going to cross out. We're going to end up with x is less than, remember our inequality doesn't change. And what is 3 plus 1, class? 4. So now we need to graph it. Okay? We're going to start at 4, and am I going to have a closed dot or an open dot? Fatima?
Closed.
Closed, because it is including 4, right? So we're going to have a closed dot. Now it's less than. Am I going to go to the right or the left? The left, because the arrow is telling you that it's less than that number. So we're going to go all the way down here. Good. Now, does somebody want to give me a number to put in to check? Riley?
3.
You want to do 3? Yeah. Okay, let's try. So 3 is on the number line. It's shaded, so it should be good. So we're going to put in 3 minus 1 is less than or equal to 3. 3 minus 1 is what, class? 2. 3 minus 1 is less than or equal to 3. Is 2 less than or equal to 3? Is 2 smaller than 3?
Yes.
Yeah.
Yes.
Thank you. So it checks out. Okay, so you're going to do the next 3. You can help each other in your groups if you need to, but you need to do it with a whisper. If you have questions, feel free to ask me, but I want you to finish the last 3 on these examples. Got it? All right, you guys have a great day.